We are now ready to learn about arrays, and I would like to introduce the idea from the broader perspective. So we talk about computational problems, we talk about data structure, and think about array is simply just one possible data structure you can use to solve any given well-specified computational problem. And we talk about algorithms, basically the steps that we'll take to manipulate the array in order to output the correct value. But let's talk about these terms one by one in a single slide, and then we'll introduce the syntax and semantics for arrays. Okay, we talk about computational problem. It must be well specified, meaning that you should really have a well-defined input and output relationship. You can think about all the lab exercises or the programming tests that you have been given. So you always are given the well-specified problem, like what should be the input and also what the output should be. So that's what I meant by well-specified. And let's take one example here. You can think about the input is simply a sequence of n numbers. You got A1, A2, all the way to AN. It's simply just a list of numbers. You can think about these numbers are declared as input parameters for your method. And then for the output, you should also be well specified. It's going to be the maximum number max in the input list or input array, such that the maximum is larger than every other elements in the list, right? Larger than or equal to, including itself. So that's the very definition for the maximum value in the array. All right, and then we say that this is only for the definition. You can think about A1, A2, all the way to AN. They are simply just input parameters. And then what about one particular instance for the problem? For example, you can see we got specific value for all the input value in the input list. All right, so that's about computational problem. You can think about as far as this course is concerned, every time you're given a method to implement, it is a independence computational problem to solve. What about data structure? It is a systematic way to store and organize data in order to facilitate access and modifications. Take array specifically, for example. As we introduce to you the idea, the syntax and semantics about array, we'll talk about how you can store values, how you can initialize the storage in the memory, and also how exactly should you visualize the storage for the array. It will be linear, one after another. And also, how do you access the array? You will do so by specifying a valid index to say, I want to go to position, maybe number 2 at index 2, for example. And then how can you modify the value that's stored in a particular index, right? When you talk about different data structure, you always need to talk about different ways to store and organize the data. That's the idea. Finally, what about algorithm? You can think about algorithm as like a solution to your method or to your computational problem. So a solution to a well-specified computational problem, and it should be a sequence of computational steps. Remember, we talk about sequential execution of your code. So that's why a sequence of steps that will take some input values, and also you're going to produce some return value. So when we say output value, you can think about it's like a return value in the context of your utility methods, for example. Okay, and the steps in an algorithm manipulate well-chosen data structures. So here, when I say well-chosen, I'm talking already beyond the scope of this course. In this course, most likely you wouldn't be given any choices. Always, the data structure you have to use will be an array. However, once you go to the more advanced courses, you will have to make some judgment about which alternative data structure you should use. Should you use a tree? Should you use a hash table? Should you use a linked list? And etc. But for this course, we're only introducing you to the idea over here. So arrays always. But keep this phrase well chosen in your mind. So you don't necessarily have to use arrays later for your developments outside this course. Okay, so that's about these three very important concepts about problems, data structures, and algorithms. Okay, just keep them in mind, and always brush up your mind about their definitions. What I will do is I'm going to introduce to you the arrays, and also some easy loops about iterating through the array to also to initialize their values before we try to start solving problems. There are assumptions I'm making, right, just to to make our lecture more effective. Let me just tell you what my assumptions are. Number one, so you are supposed to have already completed the weekly Java tutorial videos for week number 5. And specifically, you want to make sure you go over part C1 and C2. So these are the two parts where I spoke about the syntax and also memory model for the array. It's really important for you to know about these two parts of the video. I can assume you did that, so I don't need to repeat the explanation. Number one. And number two, for those of you, again, if you want to do some extra practice to really expose yourself more into Java, you can go to this tutorial series, right? The Winter 19 tutorial series. And then, as I said last time, you will need to, if you want to go for the arrays and loops, you will be from video 20 to video 33. Okay, so these are the 13 videos. You may want to plan your time to watch them, right? Optional, but it will be useful for you. So I will leave that to your decision. All right, so these are the assumptions I'm making. So let's now continue. All right, I will just review very quickly about the syntax and semantics for arrays, and then we'll start solving problems from the next video. All right, array is simply a linear sequence of elements. When I say linear, you can think about it's simply one element after another. They're simply adjacent to each other. You got element 0, you got element at index 0, element at index 1, which will go just next to it. So it's a linear structure, okay? Like a sequence, okay? The types of the elements in an array are the same. This is homogeneous, meaning that you cannot have simply a mix of array elements of different types. You just cannot have it. Okay, so let's give you some common example for array types. An array of integers, you will say this, right? Remember, that's how you declare the array type. You'll put empty square brackets over here, and then here will be the type for every element. So this integer here can be changed to different types, or you can have array of doubles, and here you can see you see double here, or you can have an array of characters. You can see char over here. Or you can have an array of strings. In this case, you put string. Remember, string is a class name, so you gotta put capitalized, right? If you put lowercase, it's gonna be a mistake. And also an array of booleans. You can see the boolean, also primitive type. And okay, so these are the common ones. I would say if you know about these, how to declare these arrays, that should be sufficient for now. All right, but I would say the most common ones we use might just be integer double. And also string boolean. We might use characters sometimes, but depending on the application, depending on the problem you're solving. Okay. All right. Each element in an array is associated with an integer index over here, and it's very important to note the indices will start. The range of valid indices of an array is constrained by its size. It will start from 0 until the size -1. Okay. The first array, the first element is always 0 index over here. You can see 940 in this array is actually has the index 0, and then what about the second index? The second index will be 1, and etc. What about the last index? It will be the size of the array -1. For example, you can count how many elements we have in this particular array. You can count we got 10 elements. So now 10 minus 1 will tell you that the maximum index for an array of size 10 should be 9. All right, it's really important. And then I can see so the last element will be the size of the array -1. And how do you really get the length of the array? You will say array name dot length, right? That's also something we spoke about in the tutorial video. And then notice one thing here. Whenever we talk about index I-1, so that means it's the ith element. For example, if you talk about 0, index 0, that will be the first elements. If you talk about index 1, it will be the second elements. If you talk about the third elements, it will be index 2, and etc. Right? So this slide here, very easy, just to remind you about the syntax for the array, and also how you can visualize the array. So here in the slides, I don't really show you the memory model about the base address and also addressing offset. So that's something I explain in detail in the tutorial videos. I assume you have seen that already. All right, how do we initialize and also do indexing into the array? I'm going to just show you examples right away, something that's not included in the slides, but I will do that on my iPad. So this week, I wouldn't do too much about Eclipse debugging. I did it already in the weekly Java tutorial video, but I'll encourage you to try any source code which does not exist in the project I gave to you, and try that in Eclipse. It will be up to your practice, really. All right, let's now say this. Let's say we want to initialize an array that looks like this, right? With 10 elements, starting from index 0 to index 9. How do we do that? You got two ways to do it. If you notice that there are simply no patterns among the numbers, for example, 940, 880, 830, and etc. There's really no regular pattern among them. In that case, you only got two choices, right? The choice number one, you can use the initializer syntax over here. So you can simply, first of all, you will simply declare a initialize at the same line. So you would say integer, every element of the array is an integer, and an empty square brackets, and the IA, declare the array variable, is assigned to, and then curly brace, right? And then we're going to put all the numbers over here, 940, 880, and etc. So 940, 880, 830, all the way to 440. Okay, you get the idea. Okay, I don't need to write down the whole list, right? Simply means you have to fill in the numbers yourself. All right. What about the second approach? The second approach is to really have discrete assignments on the array. So what you will do is you're going to say integer array still IA will be equal to a new array objects. And how many elements do we need to do we intend to really accommodate? Because the maximum index is 9, so that means we need 10 elements. New integer array, and then you put a size over here, right? That's a syntax we already spoke about. Make sure you know how to do it. After this line here, what we got is IA is really pointing to an array over here of size 10, right? So you got index 0, index 1, and all the way to index 9. However, every element there is by default simply just 0, right? That's also something we spoke about. And how can I really make this array look like just this array over here? I need to do discrete assignments. So what I can do is I can say IA, for example, at index 0 should be assigned to 940 to really make sure it corresponds to this. So now it'll be 940. Let me do one more. And also integer IA at position 1. Position 1 over here, it should be 880. 880. So this will make sure we will change it to 880. And then you can do the rest of the 8 discrete assignments to really initialize the array. All right, I hope you follow so far. So just a very quick brush up of what we learned in the tutorial videos, right? You can see also tutorial videos for detail. Let me talk about another scenario over here. Just give you one example. Sometimes the array that you want to initialize or create, they might have some pattern existing among the members or the elements in the array. For example, this array, you can pause the video and tell me what they are, right? What kind of pattern? All right, assuming you thought about it, it's basically an arithmetic sequence. So starting from the first term to go to next term, plus 3, and also plus 3. All the way to, you can see also this one to here, also plus 3. So once I know about the very first term, I will be able to initialize for as long as I need the array to be, right? So that's just one special case, right? Not necessarily you will have to initialize an array that corresponds to an arithmetic sequence, but the pattern is really the important key. So the pattern could be different, but it can always be coded as a for loop. All right, let's take a look at this example over here. Let's now trace very quickly here. So what about the first line here? So the first line, we're simply creating an array variable sequence sig over here is basically pointing to an array of size 10. Right? You can see size 10, meaning that we're going to get 0, 1, 2, all the way to index 9, right? So the maximum index plus 1 will be the size of the array. And then what we're doing is we're saying that at index 0, we're going to assign the element to be 7. Oh, before that, remember, every element is going to be 0 by default. And then after executing this line, we're going to change the value at index 0 to be 7. That one's easy. And then from then on, we're going to automate the process of assigning each of the subsequent elements using a loop. So what we'll do is, you can see over here, we say integer I over here. So this is loop counter, initialized to be 0. I strictly less than sequence.length. So the length is really the important property you should know about the array. So what's the length over here? Sequence.length, maximum is actually 9, so sequence.length will be 10. So now let's predict right away, okay? And also we're going to say I++, meaning that what will be the value that's going to be used in the iteration. What we learned about this previously. So let's do the trace table very quickly. So that means I is going to be 0 for the first iteration, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, for all these, if you try to do I strictly less than sequence.length, which is 10, is going to be all true. Okay, all these value here is actually going to give you simply just true. That's something we know. And the very last value, so this will be the 10th iteration. 10th iteration. And at the end of the 10th iteration, we're going to increment the value from 9 to 10, meaning that it's going to give you false. So that's the point to really exit from the array, exit from the loop, right? Exit condition. All right. So now let's just run a few iterations to get you the idea about how this loop will execute. Let's see the very first iteration. The behavior for every iteration is already specified in the body of the loop over here. In this case, only a single line. Let's try to get some intuition from this line. So it would be sequence I is assigned to sequence I minus 1 plus 3. Let's think about what's really the intuition behind. So that will be a very valuable lesson for you to see how you can manipulate the indices. This will be sequence at index I. This will be sequence at I minus 1, depending on what I is. So intuitively, for example, if I'm already here, so if this is index I, and I want to say this value here should be assigned to the elements at index I minus 1, which will be this value here, and then plus 3. Intuitively, that's what it means, right? And then we want to repeat this pattern over here for exactly maybe 10 times according to the current one, right? Repeat it once, twice, third time, fourth time, all the way to the 10th iteration. It's pretty much like we want to say, to figure out this value over here, we want to say this value here plus 3. And then the next iteration, once we to figure out this value here, this which has been figured out already from the previous iteration plus 3. And then to figure this out, this one plus 3, and etc. all the way to until we figure out what this last value is. That's really the pattern we are trying to automate using a loop. Let's see what's going to happen for the very first iteration. For those of you who might be very curious or very careful, you might have seen some mistake I have made already, I hope. Right? Let's see. For the very first iteration, let's try. So I'm going to execute this, and now when I was initialized to be 0, right? I minus 1, what is that? I minus 1 is actually minus 1. 0 minus 1. And then you can see we want to say, conceptually, we want to say, in order to figure out sequence I, sequence 0, basically, in order to figure this out, but this has been there already, but we're saying that it's going to be whatever minus 1 index it is, plus 3. But the problem is, there is no index minus 1. That's why I deliberately made a mistake to actually show to you one possible runtime error that's very common, okay? If you actually got minus 1 over here, so that means when you got sequence over here, minus 1 over here. So minus 1 here definitely is not a valid index. It's an invalid index. To be more precise, it is the case where the index is way too small. The smallest index you can ever give to an array will be 0 always. So minus 1 for sure is too small. What you will get, this will be something maybe I can show to you, or I'm pretty sure you will run into anyway in your labs or in your programming test. It's called array index out of bound exception. Okay, I'll write it down. Array index out of, it's quite a long name, bounds, I believe plural, exception. It's a single word. So I would suggest you can definitely try to type in this code over here to initialize the array and still keep this mistake over here to say initial value should be 0 over here. And then you will see in the very first iteration, you're going to run into array index out of bound exception. Okay, that's a very important thing for me to mention right away. All right, array index out of bound exception. Okay, so we apparently this code is actually wrong. So how can we fix it? To really fix it, because the idea would be we always to say the current elements value should be equal to the previous one plus 3. So where should be the very first place to start? Maybe not the first element because it's being initialized to be 7 already. So we should definitely start with the second position, index 1. So I would suggest we make the following fix over here. So you're going to say rather than 0 over here, it's going to be just 1. All right. So that means this is no longer going to be the first iteration anymore. Instead, this should be the first iteration. And this should be the 9th iteration as well. Again, so how many iterations? The first iteration, we're going to figure out this element by plus 3. Second, third, fourth, fifth, 6, 7, 8, and 9. So we got 9 iterations in total. All right. Let's now see the corrective first iteration. For the corrective first iteration, we're going to say sequence 1. So that will be the initial value for I minus 1. So I minus 1 will be 0, which means we're going to get sequence at position 0. In this case, it would be 7, which was what we just initialized. So that will be 7. So it will be 7 over here plus 3, which will be 10. So that means sequence 1 is going to be sequence I minus 1 plus 3, so which will be 10. All right. So, and then we're going to increment I by another one. Let me just do one more iteration, and then you get an idea to go on. And for the second iteration, I would be actually 2 right now. All right. And then I minus 1 will be just 1. So that means we're calculating the previous term, which will be sequence 1. Sequence 1 was just done fresh, which will be 10. Right? It's simply just 10. So what we want to do is, in order to figure this out, which will be sequence 2, it will be sequence 1 plus 3. Sequence 1 is 10 plus 3 will be 13. Right? So that's the value. You can see so far we have successfully built the array 7, 10, 13, which is part of 7, 10, 13 over here. But if you continue with exactly this pattern over here, if you continue with this, you're going to get you're going to fill in all the rest of the elements. I'm not going to waste your time by doing that, but you can definitely do it by tracing on the paper, or maybe launch the debugger by seeing that yourself. All right, I'll leave that exercise to you. Alrighty. So the main lesson from this exercise over here, let me recap 2 things. Number 1, you want to be able to patternize the assignments into individual cells or individual positions of the array if there are some patterns among the elements in the array. So this is just one example. But I would say having I minus 1 over here simply tells you the index for the array can be any integer expression, right? It can be I minus 1, it can be I plus 1, it can be I minus 2, whatever that's applicable to your problem solving. And then you got to be very careful, because if I initially assign the wrong value over here for the loop counter, which is 0. In that case, I'm going to run into sequence minus 1, and then I'll get into array index out of bound exception. That's these are the 2 important details for you to notice. Okay, let me do very quickly. What about an array of strings? Very similar. Let's say, for example, how do you initialize an array, string array over here, Alan, Mark, and Tom, for example, right? So initializer will be very similar, but now the elements type is going to be string, capitalized. And then array over here, empty pair of square brackets, and then SA, string array, will be initializer. So I got Alan, Mark, and Tom. Each one of them is going to be a string. I can just put a string literal. So I can put Alan, and also I can put Mark. Also, I can put Tom over here, right? You can see it's very easy to do that. So that'll be initializer expression, pretty much like how we initialize the integer array. What about the second one? How do we do discrete assignments? Also very easy. So we'll declare the array, as always, string SA. And what's the size of the array? Maximum index is 2. So size should be 2 plus 1, 3. So it would be new. Always put the new, telling the Java runtime they're going to allocate the corresponding memory space for storing this array, and then it's going to be string. Now you can see this part here simply corresponds to this part here, and then what's the size? 3 over here. Okay, what this will do is it's going to be pointing to SA and then it's going to be an array of size 3. Index 0, 1, and 2. Initially, as we said, nothing meaningful is going to be stored. In the case of integer array, remember we simply said it's simply just going to be 0 to begin with. What about string? We will introduce to you about objects very soon after the reading week. But for now, think about string is simply storing. You simply don't store any meaningful string. So I would say anything other than primitive type is going to be null. Let me put null over here. Okay, it's simply going to store null. Let me elaborate on the null versus for reference type, maybe when we start introducing about object orientation. So bear with me. For now, you can think about the default value for string is simply just null, which means meaningless address. And then we're going to assign each one of them one by one. For example, Alan first. You can say SA at position 0 is simply assigned to Alan. This is to say, for index 0, rather than storing null, it's actually going to store Alan. Okay, so now we have done, basically this part is Alan, which will correspond to this part here. And you can also do the discrete assignment for index 1 and also index 2. I'll leave that part to you. Okay, and of course, you want to make sure you put semicolon at the end. Okay, so that's about how you can initialize the array. Let me speak a little bit more about how you can iterate through the arrays, and then we will be ready to solve many problems that I want to talk about for this week. You can either use a for loop or you can either use a while loop, as we said last time. So these two loops are expressively equivalent, so you can definitely convert from one to the other. Let me talk about this. Very important for you to see. Typically, the loop counter value will be initialized to be 0, but of course it could be 1, like the example I just spoke about, so it depends. You can think about the 0 here is really the minimum index of array. But sometimes maybe you have to do something larger than 0, it depends. And then over here, this part over here is the state condition. I want to speak a little bit more about state condition, exit condition, right? So this is the state condition. Accordingly, can you tell me what the exit condition is? The exit condition will be when this pink condition here is simply not the case. So in not the case, I strictly less than a.length, which is equivalent to I larger than or equal to a.length. Basically, this is really referring to the equal case. So when I is exactly equal to a.length, for example, let's say this. In this case, if we are if we are trying to run this, right? When I is exactly equal to ia.length, that means I will be just 10. And 10 is not a valid index anymore, so we shouldn't really go into another iteration with the value 10, right? So this is really for this purpose over here. When it is really equal to a.length, so that will be the first invalid index. And once we reach the value of the loop counter into the first invalid index, then we should really exit. So that's the point to exit. Alright guys, I hope this will help. I just want to explain to you the inside for the loops, especially when you want to apply the loop counter as the indices for the array. Okay, anything else? I think, yeah, for the while loop, it will just be the same. You can see initialized to be 0, for example, and also it will be less than a.length. However, there will be some cases where you may want to put the state condition to be a little bit different. Again, exactly what the state condition is and also what the initial value for the loop counter is, it really is really up to the application you're trying to solve. But I'm just telling you, in principle, these should be the value. All right. Okay, so let me now go back to the slides. I think we spoke about everything about arrays over here. You can see this. This just remind you, this is how you actually get access to the last elements in the array. Array name, .length, -1. If you didn't do -1, for example, if you simply just say names.length only, in that case, you're going to get into array index out of bound exception, right? Just to remind you. Okay, that's exactly how you spelled it. Array index out of bounds exception. Okay, and then so these are the two for loop and while loop we just spoke about. Okay, and then exactly what I just said. So you can just try to remind yourself about how you can specify the syntax for the for loop and while loop. Okay, so here just a little principle about how you can translate from for loop to while loop. The state condition are exactly identical, right? That's the part you don't need to do any translation. And then the loop counter I will be initialized only once. Okay, so this part is very easy. In some way, we already spoke about this principle last time, but I'm just including the principle here again, just for your information. All right, so now we will be ready to really solve a series of computational problems using the arrays and also loops.